All right, getting into the next talk here. We have a awesome presentation. Let me open this up real quick. This is called Serverless Design Transformations, and we will be Mohammed will be talking about approaching the software development lifecycle in a serverless way. And we will be exploring the baseline concepts of how to go about making the jump from traditional software development practices to cloud-native serverless development practices, with a lot of tips inside of this. And I want to say as well, I've seen this talk. I've looked at the stuff that Mohammed's created, and I just want to say that it's really robust and has some really good tips around like packaging and all those things. So without further ado, this is Mohammed Izzy from the Serverless Guru team, who will now be talking about some tips around serverless adoption.
Today's webinar of Migration to Serverless 101. My name is Mohammed Izzy, and just to give you a quick introduction about myself, I work as a developer at Serverless Guru, where we help clients transition from a traditional software development practices to a serverless first approach. And I've helped build PCI systems for our clients. I've also worked on complex event processing systems with Apache Flink. So these are some of the key things that we do at Serverless Guru. And so today's session is geared towards those folks who are new to serverless, or if you're willing to jump on the serverless bandwagon. I hope this session is informative and you can take something away from this. So let's get started. So this is what our session looks like for today. The first thing is to understand why should you even consider a serverless architecture, and how do you go about initiating the design process, some common pitfalls and anti-patterns to avoid, and then lastly, how do you iterate your design for performance and cost efficiency. So as the name suggests, serverless doesn't mean the absence of servers. It's just that the technology is based on the concept of event-driven computing, where your entire system is comprised of small modules that are wired together and then work with each other to process an event in a predefined sequence. So the benefits of using serverless is that you only pay for what you use. That is, you only pay for that compute time for the lifetime of that event, as opposed to traditional servers which are running always, even when there's nothing to process. And because serverless is a cloud managed native solution, there are less management overheads because there are no servers to patch, there are no software updates, and there's nothing to do with the underlying hardware because all of that is offloaded to your cloud provider. So it's also a lower cost of operation. And traditionally, when you were to provision servers, you always would have to sort of guess on how much offload you would expect for your application, and then you sort of expand as and when you need to scale up. Where with serverless, you don't have to worry about any of that because it all happens automatically, and you only pay for that duration of the event. And the other point is with serverless, where you actually go with a microservice architecture, which makes it easier to compartmentalize your services, and it also lowers the possibilities of system-wide failure. So when in monolithic applications, if something were to go down, your entire application is crippled, and which also means downtime for your systems. Whereas with a serverless design, if something does go wrong, it doesn't cripple your entire application, and it's only that specific service that needs to be dealt with. So also when it comes to making changes to specific services, you don't actually disrupt the entire application, unlike monolithic applications, because even a minor change in traditional softwares would require some downtime, where with serverless, all of that just goes away. Now, once you've sort of, made the decision that, okay, you do really want to go ahead and adopt this serverless design, how do you go about initiating that process? Well, the first thing to do is to not just dive in directly to the implementation step. You want to spend quality time analyzing your application's current state and sort of how it can be broken down into individual components. So what you see in front of you is a very simple Django-based web application that has different services all in a monolithic design. So you have the authentication, you have product management, you have the UI and your payment systems, all powered by one single SQL database. So any decision that you make at this point is going to have an effect on your serverless journey. So you really want to spend some time and analyze how do you split these services up and how you can leverage the cloud native solutions instead of just porting your existing stack onto the cloud. So especially when you're trying to bring in new services, if you're if you, let's say, if you need a message broker system that is going to be consumed by the other services of your application. So there are different solutions, there are different things that you can look at as far as cloud managed services are concerned. So with AWS, you have something called Amazon MSK, which is a managed Apache Kafka service, and you also have EventBridge. Now, both of them on paper might seem really good choices, but then it's only when you run certain tests and you run like proof of concepts, you understand what works best for your system. And also, when you analyze the performance and the costs that come with it, you make a more informed decision rather than just, picking a service and going ahead with it. Also, you do not want to reinvent the wheel. Now, if you observe in the previous slide, we had an authentication service. Okay, now that works well as far as a Django is concerned because their internal framework is pretty good when it comes to handling authentication. But if you were to port that to the cloud, it requires a lot of work, and also you don't really want to build something that already exists. So for example, Cognito with AWS works amazingly well when it comes to handling authentication for your services. So always opt towards using cloud managed services. And one resource that I would highly recommend looking at is a book on serverless architectures on AWS. I think it covers all the design patterns that you can think of for a serverless architecture, and it's definitely worth the investment. Now, even from an operational perspective, you also need to decide how development is going to take place because the mindset needs to change. It's not like your traditional software development approach that you can employ with serverless as well. So the first thing that you want to do is you want to train your workforce. If you want to make sure that you pick the best possible route for approaching uh, the design process. So consider also having some sort of a playbook and standard operating procedure when, as and when you evolve your training processes. So when you onboard new resources, you don't sort of keep repeating the same thing over and over again. And we also have a training course that covers all the basics for a serverless development from start to finish. So I would recommend taking a look at that as well. And the other thing is also splitting up of your services. So once you've come up with an architecture of how your services are going to be on the cloud, ideally you want to split all your services per repository. So as you can see, we have like 5 different repositories, where each service has its own repo, and this also decouples the working between different teams, so they're not reliant on each other, and also it really speeds up the entire development process. So unlike monolithic applications where you would have to, you know, have some sort of coordination between teams before you push your changes. So all of that just, it goes away with this approach. You also want to make sure that every piece of infrastructure that needs to be deployed onto the cloud is only done through ISE templates. So ISE is infrastructure as code, and there are different tools for this purpose. So the serverless framework would be the go-to tool for me. But yeah, we have other mature tools like Terraform and AWSM as well. So the serverless application model from AWS is specifically made for serverless development. So you can pick any one, whatever works best for your teams. But just it's crucial to understand that no deployment or no provisioning of resources should be done through the console, and it's only through these IAC templates. So testing is a crucial process in any with any kind of development. But with serverless, the approach can be a little different. So unit tests, you can leverage these IAC tools again, like the Serverless Framework or SAM, which provide built-in tools for you to sort of mock your inputs and see how your function behaves individually. What I would not recommend doing is trying to emulate calls to the cloud services locally on your system, because there are tools for this that provide uh, you know all of this just packaged into one uh, big solution, and I feel it just adds on more effort, and it's more time consuming as well. So the actual testing that you want to focus on is integration tests, because the services by themselves might work perfectly fine, but it's only when you integrate with the other microservices of your application is when you see some bottlenecks or some issues. And you want to test as often as possible to make sure that, the system, the entire flow behaves as expected. Now, there are a bit of common mistakes that tend to take place, and you want to make sure that you sidestep them when you're in your development process. So the first thing to ensure that every function should do only one specific task. So the single responsibility principle is something that you should keep in mind. The simpler the functions are, the easier it is to maintain them. You don't want to have too much of logic on one function. Try and split them up into as many functions as possible, and that's perfectly fine. So synchronous functions are those functions which sort of wait for tasks A, B, and C to happen before it can complete its execution. So you don't want to have too many of these functions. You ideally want to have a function where you just fire and forget, and that function can do its job independently. The choice of programming language can definitely have a effect on the overall performance of your application. So if your existing code base is on compiler-based languages like Java and C Sharp, you you may want to consider porting to languages like Node.js or Python, because uh, yeah, the performance benefits are definitely worth making that change. It might seem like a tedious task at first, but then you want to make that decision sooner than later, because as your application evolves, it gets all the more complex and expensive too. So DRI is a very common concept. Don't repeat yourself in code, and that's fine. But when it comes to serverless, you ideally want to reuse the logic across functions, but not the functions themselves. So imagine that you have two different service teams, two different microservices that share a common function. And what will happen is you create some sort of a dependency between each of the services. So it's better to have a single repository which has the logic which you can reuse across different functions than just having one function reused by different services. And if you have large size libraries, maybe 80 MB or more, that are seldom updated, you don't want to use them as part of your deployment package, but rather you want to create something called Lambda layers, which are like pluggable units of code that that any function looking to reuse a library can just attach it as part of that service, and that's it. So again, uh, layers should not be considered as a way of reusing logic. I mean, only if the library is not updated too often and they're large in size. So if you remember, we also spoke about synchronous functions in the previous slide. So if you need some sort of orchestration where a function is waiting for something to happen before it can complete its execution, then what you want to ideally do is use step functions on AWS for that purpose. Because step functions is, think of it as a workflow that will handle the processing of any event, and it does it in a sequence that you define with error handling and um, passing on the result of one execution to another module within that workflow. So orchestration is I mean, the best tool for orchestration is step functions. Even from an operational perspective, it's recommended to have multiple AWS accounts for different stages of your application as opposed to just having one single AWS account, because it gives you more control, and also you get the benefits of consolidated billing once you sort of you create like multiple accounts in an AWS organization, and that would give you that will allow you to enforce policies between different accounts, between like dev or a production account. And uh, also billing becomes a lot easier because it's all grouped together. Tagging is something that you definitely don't want to miss on. It can be a really powerful tool, especially when it comes to generating reports, business unit, enforcing certain policies on certain specific resources. And also, if you want to apply certain changes to only certain areas of your application, it's very much possible with these tags. So we have an excellent white paper from AWS that defines tagging strategies, and I would recommend going through that for this. Even the choice of data store. So when you go for a microservice approach, uh, usually each microservice will have different data needs, and something like DynamoDB would serve perfectly well for these data needs for every microservice, because DynamoDB can scale on its own at really high workloads. And SQL databases, yeah, if your core data is managed on a SQL database, then you could still keep that aside for storing all transactional data. But if it comes to like transient storage, you really want to leverage a NoSQL database like DynamoDB, because, and again, it's serverless. So also the idea of migrating to a NoSQL database is definitely plausible. It might seem like a Herculean task at first, but if you understand your access patterns and you have complete knowledge of your schema, then it's very much possible to make this a reality. So DynamoDB book from Alex is definitely a resource that really expands on this approach of single table design. You also want to ensure that the data access between services is only through APIs, and no microservice should have direct access to your relational databases. Um, Also, to ensure that the database, when you hit peak loads, you don't sort of cripple your application. You want to have different reader and writer instances for relational DBs. So Amazon RDS or Amazon Aurora both have these capabilities, and you should definitely leverage them for this purpose. From a security perspective, like traditionally, so in monolithic applications, once the outer boundary of your application is compromised, like your firewall, then I think I mean, your entire application is exposed. Where with microservices and especially on cloud native solutions, you have the ability to assign specific granular policies for each resource. So even if one area of your application is affected, the blast radius is only limited to that service and not to the entirety of your application. Now, so this is why it's crucial to follow this least privilege principle, wherein you assign only those policies which your functions or your other resources need to work with. Wildcards might seem like the easiest thing to do. You just want to use wildcards and be done with it, but yeah, you shouldn't be doing this. Even handling um, sensitive information like API keys or anything like connection strings, they shouldn't be hard coded with your code base and committed to your repositories. You want to use the managed services like the secrets manager to always place these sensitive items over there. Um, Also, a quick tip that if you do actually utilize secrets manager, as your application workload increases, you're going to be making that many calls as well to retrieve those sensitive values. So you want to probably implement a caching mechanism for which we already have a pattern. So if this is something that you need, please feel free to reach out to us and we will help you out. The last step over here is to iterate for efficiency. So once you have at least have a base design of your serverless architecture, how do you sort of improve it for a performance and to make it more cost effective? Now, optimization is only possible when you have data to work with, right? So with AWS, we have X-Ray, which allows you to trace all your invocations with Lambda, and how long it takes, what was the duration of that invocation, and how much memory was used. So with these values, with historical values, you can make informed decisions on managing the memory and the invocation time of your microservices. We also have third-party tools like Dashbird, Lumigo, and Tundra, which are actually developed with a serverless mindset. So they are excellent tools as well if you would like to explore them. So fine tuning, like I said, it's only based on the values that you can gather from the observability tools. So you don't want to guess the numbers that you assign for your functions because every service is different. And so fine tuning is an iterative process that never really stops. So cold starts. So cold starts is something that happens when your Lambda containers have not been invoked for long periods of time. I think it's over 10 minutes. So there's an added latency that comes with every invocation when your container is not in like hot state, as you might call it. So to improve cold starts, what you can ideally, the first and the most simplest thing that you can do is work on reducing the packet size of your Lambda functions. And to reduce, so if you're on Node.js, we have bundling tools like ESBuild and Webpack. Um, I I strongly recommend using this. In fact, let's take a quick minute to even show you what sort of an impact these tools have. So what I've done is I've just created a simple function. I mean, it does nothing, but if you notice, I've made sure to import all these libraries that would be required as part of the execution. And what we do is, so the first step that I'm going to run is by just packaging those functions, the function without the ES build tool. So you can use Webpack as well, that's fine, but essentially both work in the same way. And the ISE tool that we are seeing right now is the serverless framework. So if you notice, so this is your package Lambda function, which is 6.8 MB, and this is without the bundle that I was talking about. So this is just including all the modules that you need as part of your application. Now, if you were to implement ES build, and now the packet size is 3.1 MB. That's almost a 50% reduction in your package. And this is why this is one of the things that really helps in bringing down cold stats. So yeah, I highly recommend doing this for all your functions. Also, when you work with the SDKs or any other library, you always want to import specific modules as a part as opposed to importing the entire library. So if for instance if you're working with S3, instead of just requiring the entire SDK, just import the specific S3 client, because that also adds on to your deployment packet size and optimizing imports. So even in terms of processing events, you want to ignore those events that are not of interest. What I mean by that is, let's imagine that you have a Lambda function behind an API gateway, and that Lambda function expects certain values present in the body of the request to continue its processing. Now, if those values aren't present, then yes, the execution just sort of fails. Now, you could have a custom logic before you actually begin the processing to ensure these values are present, and that's fine too. But then you could leverage the API gateway request validation feature that allows you to check or inspect the body of the request against certain regular expressions to see if the data type of certain values is either a string, boolean, or a number, and only if it matches the criteria, the request is then forwarded to the Lambda function. So you, in fact, don't have to even invoke your function and place any custom logic for that purpose. Another example that I can think of is when you use S3 as an event source for your Lambda functions, you could filter out events of imagine a bucket containing a mix of different file types. So you have images, you have videos, and you have other documents, but you're only interested in processing images. And for that purpose, you can assign a prefix to the S3 invocation setting, wherein you invoke the function only if it's a .jpeg extension. Likewise, with other serverless resources like SLS, you also have the ability to ensure that a particular subscriber is only processing events when it meets a certain criteria. So every invocation does have a cost, and if you can bring down the number of invocations, you save money as well. So this is a typical high bird's eye view of a serverless architecture.
Okay, all right. So it looks like we had some technical difficulties right towards the end of Mohammed's talk there, but as y'all just saw, that we went into lots of stuff. Even saw some live coding there, which is fantastic for Mohammed around packaging and some of the easy improvements that you can do with Lambda to make your stuff even more efficient through very simple like plugins, things like that. Next up, what we have is a live debate about CI/CD alternatives from Almir and Jamit. So let me bring them onto screen here. So we got Almir, I've got Jamit. Fantastic.
Hello.